Well, hey everyone, this is Jason at Alorium Technology, and in this video, we're going to take you through our Hinj Quickstart in video format. Now, this is largely based on the Quickstart information that we have on our website at AloriumTech.com/Hinj Quickstart. There you'll find all the steps you need to take to get things up and running with your Hinj board. And in fact, there'll be some additional information, whether you're trying to do an accelerator or a snowboard. Some of this is going to be consistent. So if you've used our products before, some of this will be repeat. If you haven't, stuff will be usable or applicable toward our other hardware as well. And then we'll get into the Hinj specific stuff. Now, I can't promise that I'm going to follow this exactly, but it's going to be largely patterned after it. There may be some details down in the weeds here at the website that you want to jump in and look at. If you get stuck, come back to this. It's a great resource, and I think it'll help you along step by step. So let's get going on this. The very first thing we're going to do is talk about connecting your Hinj to your computer because it's slightly different than Accelerator Snow. So let's jump into that first. Okay, now one of the big differences with the Hinj board is you cannot power the board across USB. Because of all the extra components and modules on there, it just requires more power, and so you can't get it from a standard USB port. So we do have the power supply jack. If you bought our Hinj kit, so the box kit you can get from us, it does come with a power supply that we recommend that you use. If you have your own power supplies, we have the recommendations here. It ships with a 9-volt, 2-amp power supply. But if you have your own, you can power with anything from 7 volts to 14 volts, but you do need to have a minimum of 500 milliamp supply capabilities of that power supply. And so when you plug it in for the very first time, what you should see, the image that it'll come with, the sketch that's loaded on it, you'll see down in the bottom right-hand corner there, that bank of 8 LEDs. We'll be just doing a simple chase pattern from right to left. And then the D13 LED at the top will be blinking. And so it's just a very simple thing that when you plug it in and power it up, if you see that behavior, you know that that Hinj board is good and everything on it is hooked up like it should be. So you've got your board, you've got it hooked up. The next thing you want to do, if you haven't done that before, is install the Arduino IDE and the drivers you're going to need to talk to our board. Let's talk about that really quick. Okay, in section 3 of our Quick Start, we talk about how to install the Arduino IDE, and depending on your operating system, whether you're Windows, Mac, or Linux, we have some different instructions. I'm running on a Mac, and so what I would do is I would click on this link, and this is going to take you to the Arduino installation page for Mac OS. Now, I'm not actually going to go through that entire process right now because I have done that already. I do have Arduino installed, and so we're going to jump right to using it in a moment. But I do want to make a comment about FTDI. And so we use an FTDI chip to do the USB serial interface communication with the computer. And SparkFun actually has a really great installation guide for installing the FTDI drivers on your Mac or on your computer. So I recommend you go out there and check it out. One quick note about FTDI drivers and Mac OS is there's kind of a known problem that's been around for a few years with this, where sometimes there's some conflict and contention because of the FTDI drivers that are installed by default with Mac and what you install to use your board. And it has to do with what Mac started including as they upgraded their stuff or they upgraded their operating systems over the years. It can run into some issues. Now, what it looks like from a symptom standpoint is your USB port might disappear from the Arduino IDE when you're trying to use it. And so if you run into that and you want to try to fix it, I've got a link here. This is on our YouTube channel. This goes to a video we have about how to fix the FTDI driver issue. And we've had a lot of people go through this and use this process, and it seems to work. So if you're running into that issue, I encourage you to come back, follow this link, and you'll be able to probably fix it. It's worked for most people. Now that you have the Arduino IDE installed, what we want to do is install the board support package for Arduino so that you can actually use our boards. And that's covered in section 4. And one of the things I'm going to do while I still have this web page open is I'm going to go down here and you can see we've got this URL kind of right here in the middle of the page. And I'm going to grab that and copy it because we're going to need that when we set up the Arduino IDE. Okay, so I've got Arduino running in the background. And what I've actually done for this video is I went and I kind of blew away everything for Arduino, my libraries and board packages and all that kind of stuff. So it's kind of a fresh install for me as well. The first thing we want to do is go to Preferences. And if we go down here to Additional Board Manager URLs, when you click on this button over here, this is where we want to paste that link that I just copied. Now I do have it pasted here already, but that's where you want to put that. That tells Arduino where it can go out and fetch the information about our board package. And you'll probably end up, if you're using other manufacturers' boards, you might end up with a fairly long list of those URLs in this preferences section as well. Once that's pasted in, you can click OK. Now if we go to Tools, board and boards manager. This will allow us to go and find our board package and install it. So we can click in the search bar. If we type Alorium, we'll see Alorium Accelerate boards. Now the Accelerate boards package covers all of the boards that we make, Accelerate, Snow, and Hinge. Version 2.0.1 is the latest. We'll click install on that and we will let it do its thing. One little caveat I will share is that once in a while I will see this installing boards process kind of get hung up. It goes through like 4 stages, 1 of 4, 2 of 4, 3 of 4, 4 of 4. This particular time it went right away. But I will intermittently see it where it kind of hangs up around stage 3 or 4, and sometimes I have to cancel it and start over, and then it just works. And I've seen that not just with our package, but with other packages as well. So I don't really know what's going on there, but eventually it does work and it installs. All right, well, now that we have the board package installed, if we go to Tools, under Board, you'll see that you have the ability to select one of our boards. We have Accelerate, Snow, and Hinge. And below that, Open Accelerate, Snow, and Open Accelerate Hinge. The bottom 3 are for using our Open Accelerate methodology, which is the ability or the process for getting your custom logic onto the FPGA. That's on our boards. We're not going to cover that in this video. That's covered somewhere else. So we're going to be focusing on Hinge. We're going to select Accelerate Hinge. So let's do that. Now when we go to Tools, you'll see that that board is selected. In addition, we have a new menu item called FPGA Image. And this is where you'll find the FPGA images that we make available for you to just immediately load onto your board. And in the case of Hinge, we only provide 2 right now, a 16 and 32 megahertz version of the same mixture of accelerator blocks, floating point, NeoPixel, servo, and quadrature. And that may change over time. We may add some stuff or default, add different configurations, but currently that's what the board is shipping with. And so to be able to use this, we want to go here and make sure we've got that port selected. It'll be something like cu.usb serial something, at least on Mac. It has a slightly different name under Windows and Linux, but this is what you'll see. Make sure that's selected, and then we will be able to actually program that with a sketch. And so the sketch we'll run is one of the examples that comes included with the board package libraries when you installed it. So we go to Examples. You scroll down, you'll see a bunch of examples for Accelerate Hinge. And as I mentioned earlier in the video, it's going to have kind of that chase pattern going on right now. So let's go down and grab one called Accelerate Info and get Accelerate version. And what that'll do is that'll go out and fetch the information about our board and provide some information back to us. So again, we've got that loaded. We've got our tools set to Accelerate Hinge on the board. We've got the image selected. And now we just go here to upload, and we will upload that. And that'll dump out some information in the serial monitor. So I'm going to open that up. And the important thing you're going to want to do if you run this is down here you can see I've got my baud rate at 115/200. That's set in the sketch. And so we want to make sure that you have that set that way too. Where is it? I guess it's right here where it sets up that baud rate. And so that's what you're going to want to use. Okay, and now it dumped out the information. We can see it's a Hinge board. It's got the 16 megahertz image on it and some other information about the board, including this nifty link to a Google Forms document that if you would be willing to fill out and let us know who you are and what you're doing with our board, we'd love it. If you don't, that's fine too. But this just shows you, okay, we've got that up and running and we've got the sketch loaded on there and we are ready to go. So that's the basics of getting the board installed and looking at the example libraries, or I'm sorry, the example sketches that come as part of the libraries that are installed, and then how to just do a very initial programming of a sketch. You are up and running very, very quickly. Now let's take a quick look at what you can do with uploading new FPGA images from the list of images that we provide for you. One of the things that makes our board unique is the ability to easily upload new images to the FPGA just using the Arduino IDE. And so if you have some background using FPGAs and you've done other types of programming, either through a JTAG programmer, or maybe if you've used other Intel FPGAs in the past and you've used their USB blaster port or that path, that's something you can do as well with a Hinge board. We've made those ports and those interfaces accessible to you. But if you are using it and you want to take advantage of it, how we've designed it with our Accelerate technology and being able to use it with Arduino IDE, you do have the capability to program it through Arduino, which makes it very easy and very efficient. So let me show you how you do that very quickly. As I mentioned before, in this Tools menu, as soon as you select the board, one of our boards, you'll get this extra menu option for the FPGA image. And in this case, we just have the 2 images, the 16 and the 32 megahertz image. So right now we've got the 16 megahertz on there, and what we're going to do is load the 32 megahertz image. So I'm going to select that. And now, if we go down and we look at the image, we'll see that we've got the 32 megahertz image selected. And all we need to do is jump down here to burn bootloader, and it's going to go off and actually update the FPGA image on the board. Now what I'm going to do is I'm actually going to open this up a little bit so it's a little easier to see, and then we'll click burn bootloader. One of the things you want to make sure you do is you have the serial monitor closed, otherwise you'll get an error when you do this. Now you'll start to see these programmed CFM page, and this is going to take a while. It's a fairly big FPGA. It's the M50, so it's going to take a little bit. I'm just going to jump ahead to when it's finished programming. Okay, after a few minutes of programming, you're going to see that it finally comes to the end here of programming the CFM, and it's just going to terminate with this last line, programmed CFM page 5280. Now, normally our FPGA update script here will also reply back or report back that it's finished updating the FPGA, and it'll actually run a little get accelerate version. But I've noticed recently that that hasn't been happening, so I need to actually find out why, and then we'll make sure we update the sketch to handle that correctly, or to continue to do that so you know for sure that it's done. But I've run this process repeatedly now like this, and it is working. We're just not getting that report back. And I wanted to include this in the intro video here so you know that it still does work and you can update it in case you want to give it a try. The one thing that you do need to do that is unique to Hinj also is we need to power cycle the board after updating the FPGA image, and that just kind of has to do with some architectural stuff that's I don't want to get into in the video. But you know, you need to do a power cycle, not just a reset, but a full power cycle on the board. So I'm going to do that, and then we'll get back here in just a second. Okay, well the board has been power cycled, and let's run get accelerate version again. We'll open up the display monitor. And now when it dumps out the information, you can see up here that the image is the 32 megahertz image. So it has indeed updated from the 32 or from the 16 to the 32 megahertz image. And sometimes even just doubling the clock frequency like that is enough to really get a lot more performance out of the AVR that's on there so that you can do things that you couldn't necessarily do before with just your regular sketch code that you're running. But in addition, when you combine that with some of the things you might want to do on the FPGA or with accelerator blocks on the FPGA, it really is a valuable thing. Now 32 megahertz isn't really very fast for this FPGA. It's capable of more, but it made sense for us to offer 16 and 32 as default speeds because of the AVR core that's on there and compatibility with existing libraries. However, if you wanted to use custom clocks with your custom logic that you're designing, if you're going to be using Open Accelerate, we can support that. In fact, we have an advanced technique tutorial on our YouTube channel called Using Custom Clocks in Open Accelerate. You can check that out. We'll leave a link to that in the description for this video as well. Okay, so at this point, we've got the board package installed. We've looked at an example sketch. We've looked at installing and updating an FPGA image through the Arduino IDE. The last thing I just want to talk about is that there are still additional libraries you can install to get access to the accelerator blocks that are on the Hinj. So recall when we looked at the example sketches here, there were a bunch of them down below. These are all things that got installed. These are libraries that are installed by default when you install our board package. This just allows you to use everything that's on the board from a hardware standpoint, like the Ethernet module, the Wi-Fi module, and all the other interfaces. This gives you the ability to do that without having to separately install other libraries. However, we do have additional libraries for different accelerator blocks that you may want to use. So again, if we go here to, in this case, it's Sketch, Include Library, Manage Libraries. And once it's gone out and kind of fetched all the list of libraries that are out there, there's a lot of them, we can again search on Alorium, and we'll see a handful of them pop up. And for example, here's one called Ubidots Accelerate, and maybe that's a good one we can grab if we want to install that. This is the library that allows us to connect to the Ubidots IoT platform. So the way you would do that is you would click on Install, and it's going to install those libraries. We'll close out of here. Now, if we want to look at examples, we'll see that that gets added, and this shows up in a slightly different place. Because it's installed as a separate library, it's down here under Custom Libraries, Examples from Custom Libraries. And the one example that we've got here is the Ubi.Simple. And now this library is available to help you connect to the Ubidots IoT platform. And we've done some other videos about how to do that, so I'm not going to replicate that whole process here, but just wanted you to see there are additional libraries out there that gives our boards connectivity either or allows it to play well with other kind of partner solutions or with accelerator blocks that we have installed on the board that you can take advantage of All right, well, that is about it. Before we go, I'm just going to go back here over to the Arduino. I think I'll reload that same image that's on there when you get the board brand new that's called Hinj LEDs. And just for fun, we'll reload that back onto the board. We'll see if we can get that pattern blinking and chasing again on those LEDs that they go down at the bottom. So everything's working. We've got a board now sitting here running at 32 megahertz. Rerunning that Hinj LEDs. We've kind of stepped you through the entire process. I hope this video was helpful. If there's anything we missed, please drop us a note. Please leave us a comment and we'll make sure we fix it for you. Hope you enjoy your Hinj board. Thanks, and we'll talk to you very soon.